So this is Divya, and I'm working as an assistant professor in the Department of Biomedical Engineering at Sri Shanmuga College of Engineering and Technology. Today, let us discuss about the topic Thevenins theorem. So, with the help of Thevenin's theorem, we can convert a circuit of resistances and sources into a simple equivalent circuit. That circuit will consist of a voltage source and in series with the resistance. So, this is founded by who invented this theorem? So, the theorem was independently derived in 1853 by German scientist Hermann von Helmholtz and in 1883 by Leon Charles Thevenins, an electrical engineer with French national poster at Telegrams Telecommunication Organization. So you can see the complicated network. So this is the actual original network. This can be converted into a simple equivalent circuit. So let us see the statement of Thevenins theorem. So Thevenins theorem states that any two-terminal linear network having a number of voltage, current sources and resistances can be replaced by a simple equivalent circuit. So the circuit may consist of any number of voltage sources, current sources and resistances. So that should be converted, that should be replaced by a simple equivalent circuit. That simple equivalent circuit consisting of a single voltage source in series with a resistance. Okay, then the value of the voltage source is equal to the open circuit voltage across two terminals of the network, and the resistance is equal to the equivalent resistance measured between the terminals with all the energy sources are replaced by their internal resistances. So there are step of procedures to find out the Thevenins equivalent circuit, to draw the Thevenins equivalent circuit. So the first step is we have to remove the load and find the open circuit voltage. How to remove the load? So the load means across which resistor we need to find out the value of current or voltage. So you have to identify the load resistors that you want to analyze. So across which resistor we need to find out the value of the voltage or current is the load resistor. You have to remove the load from the circuit and creating a open circuit at those terminals. And you have to calculate the voltage across the open terminals. And that voltage is your Thevenins voltage. So we have to use the standard circuit analysis like Ohm's law, Kirchhoff's law, and the nodal analysis to find out the Thevenins voltage. And the next step is you need to find out the Thevenin's resistance. So how can you find out the Thevenin's resistance? Have to go back to the original circuit and turn off all the independent sources. So replace the old. How to turn off the independent sources? So you may have voltage or current sources, right? So that voltage sources should be replaced with the short circuits. You have to replace with the short circuit. That means you have to remove the voltage circuit and you have to short the two terminal with the wires. And you have to replace the independent current sources with the open circuits. So you have to calculate the equivalent resistance of the circuit as seen from the terminals where the load is originally removed. So you have to look at the terminals where the load resistance has been removed. Okay, so this is your Thevenin's resistance. And next one is you have to draw the Thevenins. You have to construct the Thevenins equivalent circuit. So construct a new simplified circuit. That circuit should consist of a single voltage source. The voltage source value should be equal to the Thevenins voltage in series with a single resistance. That is, the resistance value is Thevenins resistance. And reconnect the original load resistor. Original load resistor is the RL to the equivalent circuit. And now you can calculate. So whatever The circuit is simplified, and now you can easily calculate the current